So now although the joint is where we are interested in, we know that the joint distribution can never be estimated. So what is something important? Why did we move on to joint from independent? Because of dependencies. Now how do I quantify dependency? That is the question we have to ask, right? Because I moved, I know how to handle single random variable, I know how to do hypothesis testing, etc. When two random variables are independent also, I know how to handle them. But the question is, when they are dependent, how am I going to handle? Right? Now you have to come up with a measure of dependency, right? So we now know a measure of mean of a random variable, which is an estimate is nothing but your x bar, right? Sample mean, sample variance, all of it we have established for a single random variable. But when it comes to joint, what is missing is the relationship. Now how do I quantify the relationship? That is the question of interest. Now the relationship itself could be complicated or could be simpler. Remember, we always do this unknowingly or knowingly, we always estimate the relationship. When you go to a new place and there are people, when you go to a hostel or a PG or whatever, or in a lab, what do you model unknowingly? How people interact with you, how people interact among themselves, who all gel together closely, who all do not go together, right? How is the lab environment, how is the relationship of the, most importantly, how is the relationship of the students with the faculty, is that comfortable to you? These are the questions unknowingly you will model. Whether you want to know it, do it voluntarily or involuntarily, this is what you will be modeling if you go to a lab, right, any new place. Now over a period of time somebody was close, the group was close, and then you see a transition, then you know something has gone wrong, right. So we always model the relationships, we do not even model anything absolute, we model relationships. But these relationships, is it linear? Not really, not at all. Imagine two guys, the relationship, and when you put a third guy or a girl, the relationship obviously changes. That is the best example, right. So now the relationships are always in practical, in a human sense it will be non-linear, but how do I define non-linear relationship? Very hard. Why? I could have a x squared y cube relationship, I could have a x power 4 y power 4 relationship, I could have exponential of x and exponential of y related, there could be exponential relationship between x and y. So that opens up a Pandora box, and again keep in mind, today all this whatever machine learning techniques try to learn only the relationship between random variables. The only thing it does is it is learning the non-linear relationships, and that is also the reason why there are so many techniques out there. Why? There is no one non-linear relationship, there is no one non-linear relationship, there could be myriads of non-linear relationships, okay. How and x and y are related, if you say just simply non-linear, then it means it could be anything, and that is when each of the machine learning techniques try to estimate the non-linear relationship in a different fashion. But what is important before going to non-linear etc. is to understand the linear relationship between x and y, and linear relationship there could be only one, very simple, okay, and that is what we are defining. We are defining a linear relationship between x and y, which is expectation of x minus mu x into y minus mu y. Remember, mu y and mu x are constants, so I can eliminate. When I talk about relationship, what do you think about? You talk about how people move together, vary together, right. So you do not talk about the constants at all. So that is why you remove the constants and look at how the two random variables are linearly related. Where is linearity here in this equation? Why is this equation only telling linear relationship? You want to be thorough, you want to understand bit by bit rather than hand waving. Why is this telling only linear relationship? X minus mu x into y minus mu y. Why is it linear? I did not simply put all the powers are raised to 1. I did not put x minus mu the whole square into y minus mu the whole cube. I am only looking at first order relationships. Okay. That is why it is a measure only of linear relationship between x and y. These are fundamentals. Okay. When they say correlation is a covariance is just a linear measure, the reason is it is raised to the power just 1 and you are only looking at first order interactions. Okay. And now the name why it is covariance, because you have removed the mean and you are looking at how x and y are moving together. If I replace y equals to x, what will happen? Suppose y equals to x, what is sigma xy? This is nothing but variance of x. Okay. So that is why it is called covariance, how x and y vary together after removing the constants. Does it make sense? And it is only a measure of what? Linear relationships. That has to be kept in mind. So that is why whenever you know that the relationship is linear, you can get a unique solution or you can get a very good model. Why? There is only one relationship which we can define. But when you say non-linear, the possibilities are infinity. Okay. And therefore, each of the method will estimate the non-linear relationships in a different way, leading to different methods. Okay. So now these are various values of covariance. So if you say in the first graph x and y, the relationship, repeat, this is nothing but expectation of x minus mu x into y minus mu y, and if you expand, what is this? This is nothing but expectation of xy minus, okay, if you expand it you should get this 4 terms, okay, plus mu x mu y minus 2 mu x mu y. So you will have expectation of xy minus mu x into mu y. Okay. Now if you look at the first graph, x and y have positive covariance, right. This is positive covariance. Why am I saying positive covariance? X is increasing, y is also increasing in a linear fashion. Keep that in mind. I am only talking about linear relationships. And here x and y are again linearly independent, linearly related, but in a negative fashion. That is why I showed you the PDF. It was a triangle which was going in the opposite. Okay. And in this case, the relationship, the linear relation should be 0, because it is a squared. Basically, there is, you cannot see any relation between x and y. And what about the fourth graph? Is x and y related or not related? I want to ask whether the random variables x and y, are they related or not related here? Huh? Related how? What is the nonlinear way? It is a equation of circle. It is nothing but x square plus y square equals to r square. But you could still get a 0 covariance. You could still get a, why? You could or you need not. It could be any number. But what does covariance tell? It tells you only the linear relationship. Okay. So 0 means it is not linearly related, that is all. If your covariance is 0.8, so we will look at it, covariance and correlation. So any value of covariance indicates only the degree of linear relationship between two random variables. It never talks about non-linear relationship. So that has to be very clearly kept in mind. Okay, when you are developing a model, non-linear model, and when you say my correlation is this, what does it mean? Basically stupid. Why? When you develop a non-linear relationship, you do not care about correlation or covariance, because covariance is when you build a linear model. It is only for measuring the linear relationship between x and y, two random variables.
So here you are saying like for a linear relationship, the solution will be unique. So here for a particular x, there is two solutions. Can you interpret?
No, it is not two solutions. It is the relationship which covariance measures. Okay, when I build a model, linear model, okay, the linear relationship. In fact, now if you say what will be y equals to mx, what will be m? What is m here now? What should be m here? M should be a function of covariance. M should be a function of what? Covariance, because m measures the, m is nothing but the degree of linear relationship between x and y. Y equals to mx. What is m saying? How much y changes when x changes. That means m is nothing but a degree of linear relationship between y and x. In fact, we will later on look at it is a perfect function of covariance. Okay, it is a function of covariance. Okay. So that is what I meant. When you build a linear model, covariance will play a very important role, because that will tell you the linear relationship between the two random variables. When you build a non-linear model, I do not know what the parameters are. It is not going to be covariance, that is all I am saying. It is not going to be covariance, but it depends upon the type of non-linear relationship you are modeling, and you can actually literally do infinite relationships. Okay. So if you look at, have you heard of sigmoidal functions? Sigmoid, the S-shaped curve, some of you might have heard. In neural networks we use. What does it basically do? It is trying to model the relation between yx and x using a sigmoidal function. Your latest ReLU function for that matter does it what it does. ReLU, or leaky ReLU, or your and of course you are doing at multiple levels. So the non-linearity keeps getting complicated, and that is why neural network is a black box even today. Why? You put so many non-linearities together and coupled them, so you really do not know what is the y relation between y and x. It becomes so complicated that you do not know what is the relation between y and x, what has it built. Okay. That is why actually it is a black box today. You understand? If I build only one non-linearity, I will simply say y equals to a non-linear function of x. The non-linearity is in terms of sigmoidal function. In fact, we will learn linear regression. If time permits, we will also learn logistic regression. Logistic regression, this is the fundamental idea. Y and x are non-linearly related through a logit or S function. In fact, the building block for today's neural network is logistic regression. Every unit, every neuron is a logistic regression. You all should know neuron. What is a neuron? What is a mathematical model of a neuron? One could do. The mathematical model of a neuron is exactly same that of the logistic regression. Okay. So we will learn that. So that is only one non-linearity. Then I know the relation between y and x. If I couple non-linearities and if I couple it multiple layers, then it becomes very hard to interpret the results, and that is what today's neural network is doing, and that is the reason why you have many networks. You have ChatGPT on the one end, you have BARD on the other end. There are so many so many networks out there, AlphaPose, for the same problem, because each one of the network is modeling the relation between y and x in a very different way. But ultimately what are you modeling? You are modeling the relation between y and x, that is all. Okay, clear? So you should understand the overall ideas. So now when I come to say non-linear, it could be anything. So in this case it is circle, but still the covariance could be 0. Why? Covariance only measures linear relationship. It could be 0, it need not be always, it could be 0. So I have given a simple example to state this can happen. So I have, let us say I have a uniform distribution in the interval -1 to 1. Uniform is the easiest, all are equally likely. So now I want to compute expectation of xy, and what is it? Y equals to x squared. So how do I find? I substitute y equals to x squared, this should be x squared. So I have expectation of x cube. What is expectation of x cube? Integral x cube f of x dx. Expectation of x is integral x f of x, x cube is what? X cube f of x dx. The mean is 0. Why? Because in the interval of -1 to 1, what is the center point? Center point is the mean for uniform distribution, the mean is going to be 0. It is a plus b by 2, 1 minus 1 by 2, 0. Okay. So x cube in the interval, so -1 to 1, so 1 over 2, 1 to -1 dx, this value is 0 if you integrate. But does that mean that x and y are not related? What is the relationship? Y equals to x squared, but still your correlation could go to, covariance could go to 0. That is what I wanted to show you. Okay. So relationship does not translate to covariance, it is a linear relationship that will lead to have a non-zero value for covariance, and it could also be the case where you could have a 0.8 value. If I change the interval 1 to 2, you will get a different value. But what does it say? It simply says y and x are linearly related by some number. You understand? Y and x are linearly related by some number. Okay. But it does not mean that there could not be any linear, non-linear relationships. Okay. So these are the points which are interesting. So suppose if I give you two random variables, if you build a linear model, what are you capturing? You are only capturing the linear relationship between y and x, but there could also be non-linear relationships which you are not doing, which you are closing your eyes. Okay. So those are the drawbacks of just building a linear model. You are assuming it is linear, and if the assumption is wrong, there could be a better model. Okay. There could be a better model if there is a non-linear relationship. Your linear model y equals to mx works only when is the best model only when there is truly only linear relationship. If there is non-linear relationship, y equals to mx kind of model is a subset or basically a suboptimal model. Okay. So that is what I wanted to show. Even for y equals to x squared, you will have a problem. But suppose y equals to ax, let us say in the same example I put y equals to ax. Now y and x are linearly related through a constant a. Now if you look at expectation of xy, you will definitely have a value. That tells you what? The linear relationship between x and y is 1 over 3. Now the question arises, is 1 over 3 less or more? Is 1 over 3 less or more? Suppose the relationship I get x and y is 10, is it good or bad? We really do not know, right. So that is when we start moving on to what is known as correlation. We do not work with covariance, we work with correlation, because I actually want to work with dimensionless quantities. In x and y, x could be pressure and y could be temperature. Then what is xy? Pressure into temperature, Pascal into degree Celsius. Does it make any sense, that unit? It does not make any sense. So what do? You kind of want to work with normalized numbers, and that is when we define what is known as correlation. So what is correlation? It is covariance. I want this number to be 0 to 1, between -1 to 1 or some standard values. How do I normalize? What is the maximum value of covariance? What is the maximum value of covariance? What is the maximum value of covariance? Well, if you want to normalize, you have to normalize with the max values. That is when you can get a dimensionless quantity between 0 to 1 or minus whatever, right. So you want to maximum normalize with maximum value. What is the maximum value of covariance when y equal to x? It is variance of x, it is not variance of x into. So suppose I substitute y equals to x, what do I get? I get variance of x. When y equals to x, you have variance of x, right. Now the easiest thing, and suppose if I substitute y instead of, suppose that this is also equals to variance of y, right. So what do I normalize with? I normalize with square root of variance of x into variance of y. Remember, I cannot normalize with variance of x into variance of y, because then it will be squared into square to the power 4 quantity. So I normalize with square root of variance of x into square root of variance of y. So this will be Pascal. If the numerator is Pascal degree Celsius, the denominator is also Pascal into degree Celsius. So the essentially it has become a dimensionless quantity. So correlation is a dimensional. So what is the max and minimum value of correlation? When x equals to y, you have what? When x equals to y equals to x, you have sigma x squared divided by sigma x squared, which is 1. What is the minimum value? When do I get minus 1? When y equals to minus x, I have minus sigma x squared by sigma x squared, which is equals to minus 1. So this correlation always lies between minus 1 to 1. Clear? For any two random variables, the correlation always lies between minus 1 to 1. Make sense? Clear everyone?